Hello and welcome to this CATIA Prismatic Machining tutorial, video tutorial. Today we're going to look at the pocketing operation. We're going to be working with the same part that we've been looking at thus far, which you see in front of you. This part, if you recall, has currently two operations that you applied to this. The first was a facing operation to remove material from the stock down to this level here of this face. And then we did a profiling operation around the outside to remove material to this boundary here. I'm just going to hide the stock temporarily. So this is the face here that we profiled, or the faces that we profiled back to. And you can see in the tree those two operations, the facing operation and the profile operation, both in the tree. The question now is, what are we going to do as far as the next operation? There are a couple of things we could do. We could try pocketing out this region here. We could also try pocketing this region too, but if you notice, there is this region on this side of the part which is at a lower level to the top face here that we face down to. And the best way to remove this material here is by using a pocketing operation, even though it's not what we would typically term a closed pocket. It's actually an open pocket in this region here. There's no hard wall that goes all the way around it. The other thing to note is that this pad in the middle here protrudes upwards above what we would probably select as the bottom of the pocket, which would be this face here. So there are a couple of challenges because of this. We don't have, as you can see here, walls, so we have to actually create some geometry to help us define where these walls would be. And to do this, what we're going to do is have to go into the part design workbench. So I'm going to go ahead and expand out the part body. So this is the part body here in the PPR tree. I'm going to double click on the part body so that I switch over into the part design workbench. And what I'm going to do is I'm going to create a sketch, and on that sketch I'm going to import or project geometry so as to build a boundary that I can use in the machining workbench to define the extents of the pocket operation that we're going to be planning this with this tutorial. So to do this, I'm going to use this plane as the sketch plane. So using the sketcher tool up here, I'm going to select this plane, and then using the operations toolbar, which is this toolbar here, I'm going to go ahead and project geometry from the 3D model onto the sketch plane. So the geometry I'm going to project are these edges here. The top edge, I'm actually going to double click on the tool so I can select multiple edges without reselecting the tool. This corner, this edge here, this edge, and finally this bottom edge. So these 5 edges are the ones that we project from the existing 3D geometry onto the sketch. I'm going to hit the escape button a couple of times to get out of the tool, and then I'm going to create one more edge which is going to connect the top edge to the bottom edge. So using the line tool, I'm going to just snap it onto the top line, drag it downwards. So it's vertical but not position wise constrained. What I'm going to do is I'm going to select this edge here and the line I just drew, and I'm going to use my constraints tool to establish a coincident constraint. So now that line turns green. I'll go back to my view from perpendicular view, and now I want to trim away these ends of the projected top and bottom edge. So I'm going to use the trim tool, or actually the quick trim tool, and just remove that end and remove this end. And there we have it. So that kind of gives us, or does give us, a boundary to which we can work to for creating our pocketing operation. I'm going to exit from the workbench, and there we can see that sketch. So here's a sketch in the tree. It's actually in a geometrical set. It doesn't really matter if you have it in the part body. In this case here, it's in a geometrical set, and it's there for us to use when we start defining our pocket. So now that I have created this geometry to help me define the pocket, I'm still in the part design workbench, as you can see. I'm going to return to the Prismatic Machining Workbench, and I'm going to just double click on the profiling operation, the last operation in the tree, and that should kick us back into the Prismatic Machining Workbench. Now, if you recall, we used a 3/4 end mill to do this profiling operation. I'm going to stick with that same tool to do the pocketing out here, so we don't have to execute a tool change. So let's assume that's the case. So we're going to start by creating a pocketing operation, and if we move up to our machining operations toolbar, the second tool over is our pocketing tool. I'm going to click on that, and I'm going to select the profile contouring operation so that CATIA inserts the pocketing operation right after this. It appears in the tree, and here we have our definition window for defining the parameters of the pocketing operation. As with all operations, we start on the second tab to define geometry. We move from left to right and then back over to the first tab as we define the parameters for the operation. The illustration here shows you again in red what needs to be selected, as well as the pink color too. So in this case, this picture here actually shows us an open pocket. So you can see open pocket here. If I click on this, it switches it to a closed pocket, which we will use, of course, for some of these other pockets. But in this case, because the boundary around this part of the material you want to remove, there's no wall that we have to run the cutter against. There is over here, but not on these other sides. We will use a open pocket in order to go ahead and define this. So let's start off by first of all picking the top surface. This is where the cutter first hits material. If you recall, we face down to this surface here, so this surface actually is where the top of the material currently is. So I'm going to select this as our top surface. I'm going to also select now the bottom. This is the bottom of the pocket, and that's going to be this surface here. And as we've seen several times before, CATIA goes ahead and automatically defines things like your guide, so the walls that define the boundary of the pocket. Also islands too. This pickable cube in the middle of the picture is a way that one can use to select islands. So none of these are correct, so I'm going to go and right click on the guides, and I'm going to remove all contours, so that turns red. I'm also going to remove the island too, because that's not correct either. So what are our guiding elements? Well, our guiding elements are parts of that sketch that we just created in the part design workbench. So I'm going to go ahead and pick on the guiding element part of the definition sketch, and then I'm going to go around and select these edges that are part of the sketch. Notice that an arrow appears giving you the direction. So I'm going to go ahead and select all the way around. And I'm going to hit OK. So as you can see now, the guiding elements, or the boundary of the pocket, has been reselected or redefined, as is shown by the green here, and the red line here, which represents the edges I've selected from the sketch. These are the actual geometric elements of the boundary. Now, one thing to point out is when you have a solid red line, this indicates that the boundary is hard, meaning that the tool cannot violate this. The tool has to stay within this boundary. Now obviously we don't want the tool running into this wall here, so we do want this to be a hard boundary, but we would like the tool to move off the edge of the part around the other sides. So for us to switch from what's called a hard boundary to a soft boundary, what we have to do is click on the edge that we want to change to a soft boundary. You'll notice that it changes to a dashed line, and that means that the tool can move through that edge. So I'm going to go ahead and turn these 5 edges into soft boundaries. And of course we want to make sure that this stays hard, because we don't want the tool running into this particular wall here. We may also, if we want to, put an offset on our hard boundary. So right now this is our hard boundary here. Notice that we can put offsets. Why would we want to put an offset? Well, maybe what I'm going to do after I machine this pocket here, I'm going to come back with the 3/4 end mill, and I'm going to do a profiling operation all the way around this to create this step. So maybe putting an offset here. This distance here is 1/8 of an inch. If I were to put a 1/8 offset on this, it would leave material for me to be able to profile around to get a better finish. So let's go ahead and do this. I'm going to put an offset on hard boundary. I'm going to put a 0.125. So it means now that the pocketing operation is going to generate tool paths to 1/8 of an inch from this edge. Okay, so we have our geometry defined. Actually, not quite yet, sorry. We do have one more thing that we need to define, and that is this island, because it protrudes up from the bottom, or through the bottom of the pocket. So I'm going to define the boundary of the pocket. The way I'm going to do this is I'm going to select on the selectable part of the image for the island, and what I'm going to do is I'm going to just go around and select the edges that define the, a little bit tricky here, define the boundary of the island. There we go. And now we have the island green. You can see it here, one island. So if we look at the sketch now, all the pieces that we really need are green. Again, we're not using fixturing in this in these demonstrations, so we don't have to define the fixture. Okay, so that's our geometry. That's our first tab. We're going to just step over now to our second tab, which is our tooling tab. And because we're using the same cutting tool, as you can see here as the profiling operation, all the information about that cutting tool transfers over. If we hit the More button, you'll see all the parameters. Notice that these are grayed out, and this is because if you're reusing a tool, you can't change it in a subsequent operation that uses it, because you've defined it for the profiling operation. The only way you can change the tool is by exiting from the operation, hitting OK, and going down here to the resource list and double clicking on the tool. You can change it, but then you have to go back and regenerate the tool paths for all the operations that use that tool. So if you change, for example, the diameter of the tool, then the tool paths of course are going to change, so that's why you have to go back and regenerate it. So everything here, the geometry, also the technology is grayed out. The feeds and speeds for the tool are also grayed out. So you might be asking yourself, well, if I wanted to use a different feed or speed for this operation, how could I accomplish that? Well, that's where the 4th tab here comes in. So the 4th tab uses as default what is defined in the tool, but if you want to, you can override these by deselecting this checkbox, and you can change your machining feed rate, you can change your finishing feed rate, you can change your approaches and retracts. You can also come down here and deselect this and change your RPM if that's what you want to do. So there are a bunch of different, there is a way to override the tool, the tooling speeds and feeds within the operation speeds and feeds tab if that's what you want to do. We're going to leave this as we set them for the profiling operation, so we don't have to worry about either the feeds or speeds for the tool or for the operation. If we go over to the approach and retracts tab, I'm going to leave this temporarily on set, so we can go over and look at our first tab, and then we generate the tool paths and then come back to this and play around with our approaches and retracts afterwards. So let's move to the first tab, And this here is how we define our machining strategy. So just like with profiling, we have different toolpath styles. We can start outward and move in helically. We can start inward and move outward helically. We can move back and forward. And again, by selecting on these different options, you can see exactly what the toolpath looks like from the illustration up here. We can do zigzag, back and forth, and so on. So I'm going to work with an outward helical pattern. So we're going to start on the inside and work our way outwards. Again, we can change these if we find that it's not appropriate. The direction of cut, let's keep it on climb. So again, that's these question marks here. By clicking on these, show you if you've forgotten what climb milling means. I'm going to leave the machining tolerance at 0.004. The rest of the options here aren't important. I'm going to move next over to the radial tab, which controls the step over. So there are different modes for step over, as you recall. I'm going to use the tool diameter ratio mode, and I'm going to allow 10% of the tool to overlap between passes. The overhang, this shows you how far over the soft boundary the tool will extend. I'm going to use 50% for this. And again, the rest of these options here aren't really important for what we're trying to do right now. So that's pretty quick. That's the second tab, the radial tab. The axial tab, this is how we move downwards to get our material levels cut. So right now the mode is at maximum depth of cut, which is set to 0.2, which is what we set for the profiling operation. So I'm going to just leave that as is, and you can see that there are 4 levels that CATIA calculates based upon that 0.2 depth of cut. So the distance between the top surface and the bottom of the pocket, CATIA figures out that distance, divides it by the depth of cut, and comes up with 4 levels that are needed to remove that material. So that's the third tab, and then finally a finishing tab. I'm going to just put a finishing pass on the bottom only. We're going to leave 10 thousandths on the bottom for us to remove with one finishing pass. Remember, we're leaving an offset on the hard boundary, so we'll expect there to be 1/8 of an inch left here, so we don't really need to spend time finishing this face. This is the only other face that this pocketing operation will generate on the final part, but we have an offset on it, so it's not even going to get there. Actually, it will do some work on the island too, so that's one other place where it will leave some material. So finish on the bottom, 10 thousandths. The rest of the options we don't have to worry about, or we're not going to worry about for this operation. And now we're ready to generate our tool paths. I'm going to go ahead and do this, and then once that's done, come back and look at some of our approaches and retracts depending on what we see. So I'm going to hit the toolpath replay button on the bottom, and there we go. We can see the toolpaths that were generated. So you can see that there are 4 levels, 1, 2, 3, 4, each one removing 0.2 of an inch. And then if you look closely, there is this cyan color, which is your finishing pass. And you can see that the tool does not go through the hard boundary, but it does run all the way to the soft boundary. So the tool is actually overhung on the part on the soft boundary, which is what we want, because we want to make sure the tool clears out all that material. So let's go ahead and simulate this using our material removal mode, our full video replay mode. So let's click on this, and what this will show us is material being removed all the way from the first operation, which is the facing, followed by the profiling, and then finally this last pocketing operation. So I'm going to play forward. There's our facing, here's our profiling. And then here's our pocketing operation. There's the finishing operation there. So as you can see, there's some material left here. Also notice that there's a big piece of material also left on top of the island, which we didn't machine, and I'll show you a trick as to how we can deal with that in a second. There are a couple of ways one can deal with that, so we look at those options in a second. So one other issue that we need to address, in addition to the material on top of this island, is we'd like to leave a little bit of material to do a finishing pass around the island too. We did leave some material on this face, but that was because we used the hard boundary option. We'd also like to leave maybe 10 thousandths around the island so that we can finish it later on with another operation. So let's hit OK here and go back and just make that one change. What I'm going to do is I'm going to come down here to offset on contour, and what this will do is it will allow me to offset the tool paths from the contours that are specified. So it will add a little bit of extra material here, but because I'm only going to add 10 thousandths, it's not going to be too bad. I'm more concerned about the island for this, doing it for the island. So I'm going to go here, double click on offset on contour, and I'm going to add 10 thousandths. So when I generate my toolpaths, the toolpath that does this contour will be offset 10 thousandths, so there will be that 10 thousandths to remove. Okay, so this is the end of this pocketing operation. I do have to deal with this wedge of material on top of the island. So what I'm going to do is I'm going to hit OK. If we look at our tree now, we have the pocketing operation present. What I'm going to do now is I'm going to create another pocketing operation, basically to remove that material on top of the island. To do that, one can simply, if you're going to use the same tool, one can simply copy the operation, an existing pocketing operation, and then I'm going to right click on the pocketing operation and paste it. So I've now copied that operation, meaning everything that was defined under pocketing.2 is now defined under pocketing.3. I'm going to go into pocketing.3. So you can see that what gets highlighted is pretty much all the geometry definition that was defined under pocketing.2, which of course is going to need to be changed for the top of the island. So let's go ahead and do that. I'm going to go to the second tab, and pretty much everything here except the top needs to be changed. So I'm going to go ahead and remove the bottom, remove the island. There are no islands, of course, machining the top of this island here, and I'm going to remove the guiding element. So let's start off by selecting our bottom, which is just the top of the island, and notice that CATIA automatically selects the guide curve or the boundary, and in this case it selects the boundary of that surface I picked for the bottom. And it's a little bit hard to see, but if you zoom in, you can see that the boundary is dashed. It's a red dashed line, which means that it is actually a soft boundary, meaning that the toolpaths will be generated to overlap the boundary. It won't be contained within the boundary. So let's just set our offset on hard boundary to 0, even though that won't come into play here. So that's our geometry definition for the top of the island. We're going to use the same tool, the 3/4 end mill, so we don't have to redefine that. We don't have to redefine any of our speeds and feeds that we've set, that were set in the 4th tab either. As far as our strategy goes, again, everything here should be the same. Our mode of cutting should be climb. We should be doing outward helical, radial, the same as before, the axial, same as before. Finishing, let's say we're going to finish on the bottom only, so we get a nice surface on the top. 10 thousandths is a good finishing allowance to leave. If anything is incorrect, we can always come back, of course, and change these, but let's just go ahead and generate the toolpaths to see what we get. And what we see here is the tool moving downwards. Notice that we have a large outer pass, or inner pass, and then a smaller outer pass. Let's just go ahead and simulate this. I'm going to just speed it up here with the slider so it runs true. And there we saw the cutter cutting down the top of the island down to the correct depth. Let's regenerate the tool paths. So that will work to get this wedge of material that was left from the first pocketing operation. Again, as you can see, there wasn't too much that needed to be changed in order to do this. Okay, so we've finished this first pocketing operation. Let's go ahead and talk a little strategy before we continue as to how to machine this part. There are a couple of things that one should notice. First of all, there's this step here, and I mentioned previously that a profiling operation would probably be needed to complete this. There are also a bunch of other pockets. There's this pocket here that has to be machined out, as well as this pocket over here. One thing you should do is check, as I've said previously, the radii of fillets in your pocket, so you know the minimum size of a cutting tool that you can use, or the largest size, sorry. So I'm going to just measure these radii in here just to check these again. So this requires maximum size, 3/4 end mill for you to be able to clear out this corner, which is a tool that we currently have. And the same thing is also true over here for this pocket, I believe. Let's check the radius. Yes, 3/4. So we know that we need a 3/4 to clean out those pockets. So I think a good strategy here would be, since we already have the 3/4 end mill out and we're machining pockets, we might as well just dive in and machine out the rest of this as well as this, and maybe come around and do a profiling operation afterwards, maybe with that same 3/4 end mill to clean up this face here. Before we do that though, I'm going to continue that approach where I copied and pasted the pocketing operation. To make sure that I don't have too much work to do though, what I'm going to do is I'm going to play around with my approaches and attracts first before I start copying the operation. It looks like I'm going to have to copy it 2 or 3 additional times. So let's go back into pocketing 2, and what I'm going to do is go to my last tab, and I'm going to go and set the approaches and retracts for different types of moves. Now there's a separate video that gets into this into more detail, so if you want to focus on this topic, you should refer to that video. I'm going to try to go through this pretty quickly so that we can move ahead. So the approach is our initial approach to the operation. Our retract is our final move away from the operation. I'm going to go ahead and set these using this build by user option here. Right now you see there's a plane and a move that's set up as a default. However, what I'm going to do is I'm going to clear this. So using these buttons down here, I'm going to delete or remove all motions. So right now there are no approach moves, and I'm going to go ahead and use a simple axial move, and I'm going to set the distance that I'm going to move to be larger than the depth of material that I remove during each pass, which, if you recall, is 0.2. So if I set this to 0.3, it should allow me to stop the tool to begin a feed move, or an approach move, before I hit material. And if you remember, the approach feed rate was set to 8 inches per minute, which should be fine. So I'm going to set this to 300 thousandths, hit OK, and I'm going to do the same thing on the retract. I'm going to clear or remove all motions, and I'm going to retract the tool upwards 300 thousandths at the end of the operation. I'm also going to activate my clearance move, and what this means is that before I get to an approach which is 300 thousandths above the toolpath level, the tool is going to rapid from the clearance plane or the safety plane to the start of that approach move, and then it's going to switch to the feed rate of 8 inches per minute and feed to the depth. Similarly, at the end of the cutting motion, the tool is going to retract at the retract rate 300 thousandths and then switch to rapid and move up to the safety plane. So that's what this does, activating the clearance. Linking retract, linking approach. I'm going to set these two. Again, I'm going to just set these using a move up to the safety plane. So I'm going to activate linking retract, linking approach using the right mouse button and the context menu. And in this case, I'm going to add a move, an axial move, up to a plane, which is this tool here. And then for the plane, in this case, I can go all the way up to the safety plane. So So let's go ahead and select it, which is over here. So I now have a move up to the safety plane, and I'm going to do the same thing for the linking approach. Select the safety plane here for that. Return in a level, retract, return in a level approach. You want to set this if there's a possibility that the tool is going to be lifting and moving around within a level. For the most part, I'm going to just go ahead and do this. It's hard to tell sometimes if the tool is going to do it. It depends upon the geometry of the pocket that you're machining. So I'm going to go ahead and activate it. And just like with the approach and retract, I'm going to just use an axial move of 300 thousandths to do this. Same thing for the return in a level approach. So that's the approach, and the previous one was the retract. For finishing passes, let's assume that we are going to be doing finishing. So I'm going to do the same thing there too. Set this to 300 thousandths. Although for a finishing pass there's less material. I'm not going to hit material 200 thousandths from the part, because probably I'm going to leave 10 thousandths, but let's just leave it at 300 thousandths in these two cases. Oops, make sure I hit the number. And of course I have to activate these by right-clicking and activating. And then return between levels, I do definitely want to set this because the tool is going to drop down multiple levels. So let's go ahead and activate, and then also set this to 300 thousandths, both for the retract and the approach. Okay, let's go ahead now and regenerate our tool paths to include those moves. And again, I can just check these quickly by doing a rewind to start. I'm going to switch to plane by plane replay of toolpath. Step forward. Actually, let's step backwards. One more. So now we can only move forward. So that's my engage move. Tool retracts at the retract rate, rapids over, switches to approach at 8 inches per minute, 300 thousandths above the depth of cut, which leaves 100 thousandths clearance before at the end of the rapid before it hits material. Here's most of the tool pad at that level. Here's the repositioning move, and so on. I'm going to simulate it just one more time just to make sure there aren't any problems. I'm going to switch back to continuous replay of toolpath, and then hit the forward button. There we go. So I didn't see any gouging, so that looks good. So I'm going to hit OK. Now that I have set up the approaches and retracts for this pocketing operation, I'm going to copy it and paste it again and use it to create additional operations. So let's go ahead and copy. And I'm going to paste it after the pocketing operation at the top of the island. There it is. And just like what we did for the operation we copied for the top of the island, we're going to go into the pocketing operation by double-clicking on it, and we're going to just change basically the things we need to change to work on it down to this level. So we've got an island here that we have to avoid. We also have this cutout here, but I'm probably going to just machine to this depth all the way through, and then use another pocketing operation to clean out this bottom tube when I'm done with this top level pocket. So the first thing I want to do is play around with the geometry. So let's go to the second tab. Obviously this is all wrong because this is based upon the operation I copied. So I'm going to start removing things, In this case I have to remove the top because I have a new top here. This is going to be the top of the material where the tool first hits material. I'm also going to remove the bottom, and I'm going to remove the contours that define the boundary of the pocket. Now in this case the island is going to be the same, so I can leave the island as selected. This is the same island that I used for the pocket on top, so we can leave that selected. So let's go ahead and start by selecting our top. This is our top here. This is where the tool first hits material. Let's go ahead and select our bottom, which is this level here. It's selected as the guide or boundary, this curve here. It actually winds around the island. Again, as in many cases, this is not correct, so I'm going to remove this, remove all contours, so that I've now eliminated what CATIA has selected as the boundary for the pocket. Now the boundary for the pocket is defined by basically these walls. So if I follow these walls all the way around on this interior here, that defines the boundary of the pocket. So I'm going to go ahead and select this using edges. So what I'm going to do is I'm going to go ahead and click on the red guiding element part of the illustration, and I'm going to go ahead and start selecting these edges. So I'm going to go ahead and start here. I'm going to go ahead and use the edge selection tools. I'm going to use the navigate on edges until an edge to speed things up. So I'm going to select this, and then I'm going to pick this edge here. And notice CATIA has now added all these additional edges. I'm going to keep selecting until I get back to here. So now there's this gap that goes from this side all the way over to here. So it's an open boundary still. If you go over here to the edge selection window, there is a tool there that says close contour with line. So if I click on this, what it does is it adds a line that connects the end of the loop to the beginning of the loop. So now I have a completely closed contour, as one can see here. I'm going to hit OK, and there we have our boundary. Now one of the things you'll notice is that the boundary is dashed. So what we'd like to do is, if you right click in the selection window here, pull up the context menu, there is an option here to swap hardness mode. So since most of these lines here are dashed or a soft boundary, we want to make sure the cutter stays within that boundary, so we want to swap the hardness mode, make it a hard boundary. Now there was one boundary that was hard, which was over here, so that obviously swaps and becomes a soft boundary, but we can simply just click on that to swap it back to a hard boundary. So now all our edges are hard boundaries. Okay, so we've defined our geometry. That's our second tab. Now if we think about it, we're using the 3/4 inch end mill. If we go to our third tab, we really don't need to change anything here. It's the same tool. We don't need to change any of the geometry. Actually, we can't do that here. We can't change any of the information in the tool within the operations, since we've already used the tool before. So the third tab, there's nothing there to change. Let's move over to the fourth tab. Again, we can leave these values as is, as was defined for the previous pocketing operation. If we do want to change it, we do have the option to do that, of course, but let's leave it as is. If we go over to the fifth tab, this is the macro tab. I just want to point out the fact that CATIA copied from the previous pocketing operation all the macros, all the approaches and retracts that were set in that operation. Now what this means is that it's really a good idea to set these macros the first time you define a particular operation, particularly if you're copying that operation and pasting it, because the macros get carried on. So it's good to spend some time making sure you get it correct with the first operation before you create more operations. Otherwise you give yourself more work. So we're going to leave these macros as was defined for the previous pocketing operation that we copied this one from. We're going to double back around to the first tab, and again, most of the options in here I think we're going to leave to be the same. We're going to work our way outwards. We're going to be in climb mode. For radial, we're going to have 10% overlap on the diameter. We're going to, in axial, be cutting because we have a 0.75 cutter. We're going to be doing a maximum depth of cut of 0.2. CATIA tells us that there are 4 levels that one has to do, so it looks like it's probably about 0.8 of an inch or 0.75 that we have to go down. And then finishing, let's go ahead and finish bottom only, so that we finish the bottom. Actually, I take that back. Let's go ahead and see what happens if we side finish at last level 2. We can always go back and change that later on. So let's go ahead and generate our tool paths. And there we go. You can see the tool paths that were generated. Notice that the tool, because the tool size is exactly 3/4, as is this internal fillet here, there is an exact point that the tool comes to a stop to. So the actual fillet's been generated by the shape of the cutter rather than by doing a G02 move in the corner. So let's go ahead and simulate this and see what it looks like using material removal. Just pan out a little bit, rotate things around. Let's go ahead. Things are pretty quick. Now notice there's obviously something wrong here. The tool gouged the side of the part. So let's back up and see if we can figure out why it did that. I'm going to slow myself down a little bit here when we get close, just to kind of get a better idea. It's probably an approach move that isn't properly set. So it actually looks like during part of the approach, it's running into the wall here. So we need to fix this. So at least we know there's a problem there that needs to be looked at. So as I said, there's a problem here. Let's go ahead and see if we can fix this. I'm going to hit OK, and I'm going to regenerate the tool paths just to see if I can catch what the problem is. And actually the problem is quite obvious. One can see here, I thought I had switched all the boundaries from hard to soft, but there's actually a soft boundary here along one of the boundary edges, and because of that the cutting tool is running through the boundary, as you can see, and that's what's resulting in the gouging taking place. So this is actually a pretty simple problem to fix. I'm just going to hit OK here. I'm going to go back to my geometry tab, and I'm just going to click on the edge actually, and it swaps the mode from soft to hard. If I regenerate the tool paths, it keeps the cutter completely now within that outer boundary. So again, that was something that we missed originally. So this looks like it works fairly okay. We may want to play around with things such as our overlap. If we want to reduce the amount of material that the cutter is taking as it advances through the machining of this pocket at each pass, we can change the overlap. So let's maybe look at that and see what we come up with. Let's try and experiment a little bit. So let's go back to the first tab, and then under radial, our percentage of tool diameter that is overlapped is only 10%. Let's increase that a little bit. Let's go up to 25%. Let's go ahead and generate our tool paths. So there's a little bit more overlap of the tool. So there are more tool paths that are required. If there's more overlap, there's more tool paths required to cover the area or remove the material. Let's go a little bit further. Let's try and increase this maybe from 25. Let's go to 50% overlap. And we can see even a little bit more tool paths in this region. It actually looks a little bit better here. If you go back to the previous overlap, you found that a lot of smaller tool paths were present because of the smaller overlap. Here we have larger connected circuits, which is probably a better thing to have than the previous. Let's go ahead and simulate this one last time. Here we go. Facing, profiling, top pocket, speed it up a bit, and then our inner pocket. Now let's just look at how much material we have left. Let's do the analyze. Let's do an apply. So we see we actually have material left on the inner pocket. It looks orange. That tells me that I have a chunk of material, something, you know, in the region of, you know, definitely above 8,000s, not as much as 0.2. And the reason why that is because of something we forgot to reset. Remember when CATIA, when you copy an operation from one and paste it, CATIA takes all the parameters with it. So let's cancel this out. Let's hit OK. Let's go back to our Geometry tab. And what we're going to do is we're going to set the offset on hard boundary to 0. So make sure that's 0. Previously it was 0.18, probably 0.125. And we're also going to set the offset on contour to 0. So these were copied in from the previous operation, and that's the reason why there was left material, 1/8 of an inch plus 10 thousandths left on the inner side of the pocket. So let's regenerate the tool paths one last time, do material simulation one last time. Let's run it through, and then let's analyze the part one last time to make sure that we got pretty much all the surfaces on the inner, on the inside of that pocket. And you can see everything is looking green, which tells us that we are getting ourselves within the tolerance zone for those surfaces. Okay, so let's cancel this out, hit OK, then hit OK here, so that we have added that new pocketing operation to our tree, as we can see here at the bottom of that particular tool change for the 3/4 end mill. So now you should really be getting the hang of this. We've got 2 more big pockets to do, so let's see if we can do them as quickly as possible. There's this pocket here which has the cutout in it. So what I'm going to do is again just right click and copy one of the pocketing operations, and then just move my mouse over the last pocketing operation under the tool change, and I'm going to go ahead and paste it. Okay, now I'm going to go into that pocketing operation and modify. Pretty much the geometry parameters are the only things that I'm going to need to modify, because I'm going to keep pretty much everything else, the tool, the feeds and speeds, the macros for approaches and retracts, as well as the toolpath strategy. So let's go in here to the second tab. What I'm going to do here is basically just remove everything, because I'm going to have to reselect the bottom. There are no islands, so I'm going to remove all of these. I'm going to remove the contours that define the guiding elements or the boundaries of the pocket, and then I'm going to remove the top. Now I'm going to have to configure this to match the type of pocket that I have. So this pocket is a closed pocket, so I'm going to click on Open Pocket to switch it to Close. Also, to the bottom is soft. There's no bottom on it, so I'm going to click on this to switch it to a soft bottom. And now I have the right type of pocket displayed here for me to go ahead and start picking my geometry. So this here defines the bottom. You still have to define a plane that defines where the general bottom of the pocket is as far as the cutter position goes. Before we do that though, let's move over the plane here and right click on it. If you have island detection on, please turn that off. And I'm also going to turn off contour detection. This means that CATIA does not automatically select or decide on what the contour for the boundary is when you pick the bottom. Both of those off, and let's go ahead now and pick the bottom. And there we go. So the bottom is picked. This stayed red because I turned off contour detection. Now I'm going to go ahead and select the contour that defines the boundary of the pocket. Possibly one could use belt of faces, but because of the way this cutout pocket flows into this upper level pocket, there could be problems here. So I'm going to just go ahead and pick edges again, just like I did previously. So let's select on this. I'm going to go around. There are not that many edges in this case, so I can pick each one. It goes pretty quickly. And then I'm going to just close off the contour with a line to connect the last point to the first point. That gives us the boundary of our pocket. Hit OK on edge selection. The last thing we need to select is the top of the pocket, and that's going to be the bottom of the previous level pocket, which is this face here. So our geometry is selected. The tool, as I said, is going to be the same, no changes here. Speeds and feeds, we leave that as the same. Our approaches and retracts, the same. And then our toolpath strategy, machining, the same. Radial, 50% overlap, let's leave it at that. Axial, 0.2, again we're still using our 0.75 cutter, so that works. Finishing, we're going to finish on the side at the last level. There's no floor to finish, so that option doesn't make sense here. So let's go ahead and generate our toolpaths. There we go. So let's go ahead and simulate this. There we go. So that looks pretty good. You will notice, however, that there is a little bit of a edge here because of the corner radius of the cutter, and that tells us something. It tells us that the cutter stopped exactly at that bottom face of the pocket. We probably wanted to go through a little bit. So let's hit OK, and let's see if there's an option that helps us do this. So let's go back to our Geometry tab, and there's this offset on bottom. So let's go ahead and double click on this, and let's say we want a cutter to drop true, let's say 50 thousandths. Let's type in negative 0.05, so it drops downwards. Let's regenerate our toolpaths, and then if we look here, we should see, if we look edge on, that the bottom level toolpath is below the bottom of the part. So the tool is going to break through, and it's going to prevent there from being a serious burr around the bottom edge of this cutout pocket. So there you go. That's our a third pocket that we've added to our process list, our setup for operation 1. Remember to hit the OK button to accept the changes. Let's just quickly jump in and do the pocketing on this side. So again, if we look at the radii in here, we see that we've a 3/4 end mill will do the trick. So again, let's go ahead now, and since this is a flat bottom or a hard bottom, rather than copying the pocket that we just created, which is a soft bottom, I'm going to go back up to pocket 4, which is one which has a hard bottom on it. I'm going to copy that, and I'm going to paste it right after pocket 5. I'm going to double click on this, and of course we have to redefine our geometry again. So what I'm going to do is I'm going to switch this to a closed pocket. Let me just remove the bottom, remove the island, remove the contours, and remove the top. So let's go ahead and start off by selecting our bottom. Pick on this. Now, if we noticed, we've got our bottom picked. Let's go ahead and select our top, where the tool first hits material, which is this top face here. And let's go ahead and select our contours. Right click on this, select by belt of face. I'm going to select this face, and then I'm going to use on the face selection toolbar, I'm going to navigate on faces until a face, and I'm going to pick this adjacent face here. So CATIA ran all the way around and picked all those other faces and brought me back to the first face. I'm going to hit OK on the face selection toolbar. If you're ever in question about what has been selected, one thing you can do is move your mouse over the element that you want to verify, right click, and then if you go down to the Analyze tool, it displays a list of all the elements that have been added to that particular selectable element from the illustration. So this is the Geometry Analyzer window. Shows that there's 16 faces that were picked. If you click on this first button below the list, it highlights the faces in blue that were selected. So this is a quick way of verifying, if you're ever in doubt, what belongs to a particular pick according to this image. So hit the OK button. I'm going to pick an island. So I'm going to select the island tool. I'm going to pick on this edge on the bottom. Hit OK. So I have now an island defined. Of course, we have to avoid this circular pad in the middle. And again, if we look at the remaining buttons or tabs, there's nothing in here that we really want to change. Maybe looking at the first tab, the only thing in here might be whether or not we want to have a finishing operation. So let's say we want to side finish, and also let's say side finish at last level and bottom, which means that we are doing a finishing pass both on the sides and on the bottom. We're going to leave 10 thousandths on both the side and the bottom to clean up. Okay, so let's go ahead and generate our toolpaths. There we go. Toolpaths. Let's go ahead and again simulate our part. Looking pretty good. The last thing that we would probably need to pocket, since we have that operation active, is just like we had the issue here with the top of this pad, we have an issue here with the top of this pad. So I'm going to hit OK here to accept this. I'm going to go to the tree. I'm going to highlight the pocketing operation that is at the top of the first pad. That's pocket 3. I'm going to copy this, and I'm going to paste it so that it shows, so a copy shows up after pocket 6. Oops, didn't work. Let's do that one more time. Copy, paste. So pocket 7. The only thing I have to do with pocket 7, if I double click on this, is since the height is the same, where the tool hits material in both cases for both pockets, I just have to come in here, and I'm going to reset the bottom so that it's properly located on the top of this pad, and also relocate the guiding element so that it uses this circle instead of this outer boundary. So let's go ahead and do this. I'm going to go and remove the bottom, and then I'm going to click on this and reselect this, and then I'm going to go ahead and remove all contours. I'm going to go ahead and select this, and then select this outer boundary to define the contour. Notice that it's dashed because I had an open, I'm using an open pocket configuration so the tool can run through this outer boundary, which is what I want to do. Again, as I said, the top surface is the same as the top surface for this pad here, so I don't have to change this. If we move across the other tabs, nothing else will change. The tool is the same, the operation speeds and feeds are the same, the macros for approach and retract, these should be set previously and they would remain the same. And then finally, as far as the machining strategy goes, radial, the percentage tool diameter over overlap is 10%. Let's maybe make that a little bit larger. Let's put that up to 50%. Our axial strategy is the same. We are cutting down 0.2 per pass, and then for finishing, we're going to finish the bottom only. We're just going to finish the top of this pad. So let's go ahead and generate our tool paths. There we go. And let's go and do material simulation, removal simulation one last time, just to verify that everything looks good as far as we've gotten. And there we go. So here's our part. We still have to do a profiling operation around the outside to put on the step that's present. And let me just do a quick analysis here to see if we've left anything that we shouldn't have left. So again, where we have cut, things look green. So the inside of this pocket here, the outer profile, the inside of this pocket, top of this inner island. As I said, we still have to remove this step on the outside here to get rid of this orange. And then pretty much after that, what we're dealing with are hole operations to machine out the holes at the corners and the center and the holes here, as well as we may do one last pocketing operation here to clean out the interior hole if we decide we want to do it that way rather than using a drill. So I'm going to hit cancel here. OK. Hit OK here to accept that last pocketing operation. And let's go ahead and save this file. We always want to remember to save our work. Probably should have saved it sooner in case something went wrong. CATIA does crash, as you probably know. And yes, that's it for today. Hope you find these instructions helpful.